Hello, I am Hansini Vijayaraghavan, and in the next couple of minutes I would like to walk you through my research at the Chair of Communication Networks at the Technical University of Munich. Now before I get into that, let me connect to the internet using this dongle and that light. Plug it in, wait a couple of seconds, and then much better now. Now if you're wondering why or even how I'm doing this, well, want to know more, because at the end of this video, you will know too. It has been predicted that in the year 2023, there will be 29.3 billion devices connected to the internet. This will be nearly thrice the population of the world. And most of these connections will be wireless connections. This causes a problem because we will slowly run out of radio frequency spectrum. This is where Li-Fi comes in. Li-Fi is light fidelity and uses visible light and infrared spectrum to transfer data. And its spectrum is nearly 1,000 times that of RF. In a Li-Fi network, any LED light source can act as an access point that modulates visible light waves to transfer data in the downlink. A user device could communicate in the uplink through infrared. Since Li-Fi and RF use different parts of the spectrum, they can work hand in hand with no interference to each other. Li-Fi has a short range but high data rate density, and RF offers ubiquitous coverage. A Li-Fi-RF heterogeneous network combines the advantages of the two. One major application area for such a heterogeneous network is on airplanes for in-flight entertainment as well as communication for the crew. This is also the use case that I focus on in my research. We look at an aircraft cabin and we have multiple Li-Fi access points, few Wi-Fi access points, and several user devices, which could be your personal device or the seat screens. All these connect to a central media server that stores your favorite in-flight entertainment. They also connect over a satellite link to the internet. We have multiple clients connecting over multiple different technologies like Li-Fi, Wi-Fi, maybe even 5G to services with different requirements. So the question that I look at is, how do we manage the network resources across these different technologies, especially a new technology like Li-Fi? Here we envision using a software-defined radio access network controller, which has been in use for wireless RF networks, and extend it to a non-RF technology and use its potential for wireless resource management. This leads to my research directions. First up is wireless resource allocation. Which access point do I assign to which user based on different criteria like data rate requirements, security requirements, and many more? And how do we do this dynamically over the course of time? I also look at handover management in such networks. As we've already seen, the unique properties of a Li-Fi network, such as the short coverage range, lends itself to frequent handovers between Li-Fi access points and also potentially to an RF access point. How do we coordinate these inter-technology handovers, and when do we make such handovers? The other aspect that I look at is environment planning. This involves planning the environment where the network is to be established. Where do we place the Li-Fi access points and user devices such that they provide sufficient illumination while also perhaps guaranteeing a certain threshold data rate? To aid in this, we also build 3D models or replicas of the environment, like an aircraft cabin, to enable us to better plan the environment. Here's a quick look at the model that we are developing at the department. That was a quick summary of my research interests. Now to paraphrase a popular quote. Internet can be found even in the darkest of times, if one only remembers to turn on the light. Thank you for watching.